Physics 251 Video Explainer Problem 7. In an electricity experiment, a 1.0 gram plastic ball is suspended on a 60 centimeter long string and given an electric charge. A charged rod brought near the ball exerts a horizontal electrical force on it, causing the ball to swing out to a 20-degree angle and remain there. Part A. What is the magnitude of the electrical force? And part B, what is the tension on the string? So before we solve this problem, it is important to draw a diagram to help us visualize what's going on. And so here we have our ball at a 20-degree angle, and here is our charged rod exerting that horizontal force. And then we have also labeled the tension that is exerted in the upward direction, as well as the weight, which is downward. And then we will also be using these two equations, the equation for the net force in the x and y direction, to solve for the magnitude of the electrical force and the tension. So when looking at these two problems, it is actually easier to start with part B, solving for the tension on the string, because if we look at our equation for the net force in the y direction, we see that we have T cosine theta minus mg equals 0 newtons, but we have both mass, we know gravity, and so we can rewrite this equation to solve for T. And when we do this, we get tension equals mass times gravity divided by cosine theta. We can then plug in our known values to solve for the tension. So for mass, we are given 1.0 grams for our mass, but we need to convert this into kilograms so that we can, when we multiply it with gravity, we will get newtons, and we will get newtons as our units. And so to do this conversion, we just divide 1 by 10 to the 3 grams and then times that by 1 kilogram, and this will give us 0.0001 kilograms. And we multiply this by our gravity and then divide it by cosine 20, and our theta is 20 because we are given that in the problem. The ball is at a 20-degree angle. And when we do this, we get that our tension is equal to 0.0104 newtons. And now that we have our tension, we can use the net force in the x direction to solve for the magnitude of the electrical force. And so when we rewrite this equation, we get that the magnitude of the electrical force will be equal to tension times sine theta. And so we will use the tension that we found as the answer to part B, and then multiply that by sine of 20. And when we do this, we get magnitude of the electrical force is equal to 0.0036 newtons. And with that, we have solved the problem.